All right, today we're going to look into section 8.5, which builds upon what we talked about in 8.4, which was slope. We're going to look at rates of change for linear functions and also a specific type of linear function called direct variation. So our learning targets are to find rates of change and to solve direct variation problems. A rate of change is a change in one quantity with respect to another, just like slope is, but a lot of times when we talk about rates of change, there are specific units such as miles per hour, right? How many miles are you going per hour? Um, and then a key term, direct variation, is a special type of linear equation that has a constant rate of change, right? Linear meaning it has to be a constant rate, so straight line. Um, but with direct variation, it always passes through the origin 0, 0. Okay, now we can always calculate a rate of change if it's linear, whether it crosses through the origin or not. So we can always calculate rates of change on straight lines. Um, but direct variation is going to be a special one where it crosses through the origin at 0, 0. So, right, crosses through right here, which meaning the x and y intercepts would both be 0. All right, finding rates of change, right? So finding rates of change, we can do that from equations, we can do that from tables, we can do that from graphs, right? For example, if I have an equation y equals 2x, right? We should be able to um, eventually just look at that equation and know what the rate of change is going to be. But what we can do is we can create a table. Remember, we started out the chapter by saying, if I want to find points on that line, right, I can assign values for x, right? 0, 1, 2, and I'll see what our change is, right? So if I plug in 0, right, 2 times 0 is 0. 2 times 1, right, plugging in 1 for x now, would be 2. 2 times 2 would be 4, right? So you should see that we are going up by 2 each time, right? So my rate of change would be 2. This one gives us units, right? We have miles here and we have our hours here. So if I look at 0, it's 35. At 1, it's 30. 2, it's 25. 3, it's 20. So if I go here, it's going down 5, right? So it's decreasing by 5 miles. And here it's each by, right, 1 hour. So this would be negative 5 miles per hour, right? And you can use negative to describe it, or you can say decrease 5 miles per hour, right? So we can use a table to find a rate of change as well. And then from a graph, and I can just pick 2 points that are at corners, right? I'll pick this one and this one. All right, so this is starting at 30 and it goes up to 60. So my rise is 30 miles. All right, so 30 miles. And then it's over, right? This unit's down at 1, so that goes over 1 hour, right? So that is positive, right? So 30 miles per hour. Or you could write that as increase of 30 miles per hour. Now, it didn't matter what 2 points I picked. For example, I could have picked here and here, right? So if I rise up from 60 to 120, that was an increase of 60. But now look, I'm going over 2 hours. So my rise was 60 miles. My run was 2 hours, right? If I simplify 60 over 2, that would still give me 30 miles per hour, right? Since it's linear, straight line, it's going to be a constant rate of change. Now, we said a specific type of linear equation is direct variation. So if I look here, direct variation, what makes it direct variation is if it crosses at the origin, right, 0, 0, and is linear, right? And we're going to pretend that I can draw straight lines. It's supposed to be a straight line. So yes, that would be direct variation. It's linear and goes through the point 0, 0. Okay. Now, in number 2, this is a linear function, but it does not cross at 0, 0. Okay, so no, right? And the reason is it does not cross through 0, 0. Number 3 crosses at 0, 0 and is linear, right? So that's yes, direct variation, because it's both, right? I'm just going to write both here. Now, the last example, I can see it crosses at 0, 0, but it has this wave to it, right? So it's not linear. So that's no, not direct variation. And that's because it's not linear. All right, so we've been talking about linear equations, right? Straight lines, constant rate of change. And today we're just going to add in direct variation, right? And all that means is that it crosses through 0, 0, and it's linear. And the equation looks like y equals some number times x, right? And the number, the letter they use is k, right? It's the same as m, right? It's the same as slope. It's just that there's no plus anything over here, plus some number, right? So it doesn't have this part. It's plus 0. So that means that it would cross at the origin, right? So y equals 2x would cross through. Y equals 5x would cross through. Y equals 1/2 x would cross through at 0. So this is going to be a special type of linear equation where there's no plus a number at the end or minus a number at the end for that matter. So it's a relationship where x increases in value, y increases or decreases at a constant rate. Okay. So again, when we were talking about slope, right, we used, right, the value of m. K is the exact same thing. It's just a different variable for this type of function where there's no plus a number at the end, right? It's just you're simply multiplying your variable by a constant rate. Okay? Now, to say something varies directly means that it crosses through at 0, 0. Okay, so I don't have to worry about adding or subtracting any numbers. And we say y varies directly with x. Okay, so let's look at some examples. So it says if y varies directly with x, write an equation for each example below. So y equals kx, right? Where I have to find what am I multiplying x by to get y. So my first example, I can look at a lot of these and figure out what it is, right? 2 times what gives me 10, right? We should know that it's 5, right? So my equation there would y equals 5x. Okay, now let's say that we didn't know that, right? And it doesn't always end up being whole numbers like 5. Sometimes it's fractions, sometimes it's decimal. So what we can do, if this is my general equation, y equals kx, it tells me what x is, so I can plug that in here. And it tells me what y is, I can plug that in here. And I'm solving for k, right? So 10 equals k times 2, right? To solve for k, the inverse of multiplication is division. So I divide both sides and I get k equals 5. So then my equation becomes y equals 5 times x. Okay. Take a minute and see if you can figure out what x is multiplied by in each of these equations to give you y. So pause the video here, see if you can solve the equation. All right, let's see how you did. All right, y equals negative 2x for the first one, right? And negative 2 times 4 is negative 8, right? And you can always check your answers here, right? I could say if this is my equation, right, I'm going to plug in negative 8 for y, and I'm asking, does negative 2 times my x value, right, of 4, does that check out? Does negative 2 times 4 equal negative 8? And the answer is yes. So this is my equation for that varies directly. And this is the only time where you can write an equation like this only knowing one ordered pair, right? Because when x is 2 and y is 10, another way to write that is 2, 10, right? And typically we need 2 points in order to uh, write an equation, right? But really, when it varies directly, we know the other point is 0, 0, right? So if I used my slope formula, my two y values are 10 and 0, and my two x values are 2 and 0, right? So that would be 10 over 2, right? Remember, that's how we got the 5, which equals 5. So there's my slope. So when it varies directly, even though it only gives us this one point that's on the line, we also know that 0, 0 is the other point, and that's how we can calculate the equation for that line. All right. Looking at number 3, should be y equals 4x. Okay. Then number 4, a little bit tricky, and you might have wrote the equation y equals and said x divided by 2. Okay. Um, these are the same, right, equation. They're x divided by 2 and 1/2 x are the same equation, but we want to write it like this because we want to keep the form y equals k times x, right? We don't want to write it with division, we want to write it with multiplication. So multiplying by a half, right, is the same as dividing by 2. So this is how you want to write that equation. 10 times 1/2 gives me 5. So nice and short there today for section 8.5. Your assignment to try is right here, starting on page 396. Okay, and it starts off with finding rates of change. Okay, and remember, you can always find rates of change. It does not have to be direct variation to find a rate of change. Okay, and then it goes into number 14 and 15. We'll be writing equations just like we did um, right here with varies directly. And then 24 to 26 and number 28 are review questions. All right. Hope you have a great day, and we will talk to you soon.